Recall the fact that the ordered pairs of the inverse function are the reverse of those of the original function. So when we look, for example, at the graph of the function f of x equals 2x plus 3 and its inverse function f inverse of x equals 1/2 times x minus 3/2, their graphs are mirror images with respect to the graph of the line y equals x. Again, we see that the ordered pairs of the inverse function are the reverse of those of the original function. Let's pick some ordered pairs to visualize that. The ordered pair -1, -2 of the inverse function is the reverse of the ordered pair -2, -1 of the original function. And the ordered pair 3, 0 of the inverse function is the reverse of the ordered pair 0, 3 of the original function. So their graphs are mirror images with respect to the graph of the line y equals x. Let's look at another example for the sake of practice. F of x equals x cubed and f inverse of x equals the third root of x. Recall that the graph of the cubic function f of x equals x cubed looks like this. We see that this is a one-to-one function because when we draw a horizontal line, the horizontal line intersects the graph only once at any point of the graph. And from the previous example, we know that the graph of the inverse function of a function reflects about the graph of the line y equals x. So the inverse function of the original function is going to look like this. This is an easy way to graph inverse functions of the original function. Recall that you first have to check if a function is a one-to-one function to know if it has an inverse function. If that's the case, you can draw the graph of the line y equals x. And reflect the graph of the original function about it. To get the graph of its inverse function. Very simple.